This projectile problem is different than all the ones we've done so far. What I've added to this one, what I've left showing up in the typing here, is the fact that it's moving upward and sideways when it got launched. It's an unrealistic question. It's just a stepping stone to get us to how we're really going to word our projectile motion problems. Just something to get you thinking. If I were to doodle a picture, I'm going to try and add it where Einstein is. When Einstein's 10 meters above the ground, so let's say the ground is down here. He's 10 meters above the ground, so this distance would be 10 meters. He's moving up at 5, and he throws a baseball or a ball sideways at 8. So the ball is doing two things. It's going up at 5 meters per second, sideways at 8 meters per second. Projectiles always follow parabola, so this is going to fly in the air. A little bit of a different parabola. It doesn't start moving horizontally. And the question is, where does it land? So following our same sort of method, draw the picture, think about the numbers, think about the unknown. In this case, the unknown is in the horizontal, so I'm going to start with the vertical. In the vertical, I know that the gravity is 9.8, and that's pulling it down. It ends up hitting the ground, which is 10 meters lower than it started, so that means its displacement is 10 meters, also down.
Miss Wood, please call 5502. Miss Wood, 5502.
What's different though, it was thrown upward. So I don't have a 0 for my V1 anymore. The V1 this time is 5, and it happens to be upward. Similar to before, I'm going to use those three things to solve for time. As we practiced in kinematics, opposite directions have to have opposite signs. I don't care which way you go. Most people make down negative and up positive. If you flip it around, we'll get the same answer in the end. I'm just going to crank it out with down being negative. If you've gone ahead and done this with down being positive, as long as you've been consistent, we'll get the exact same answers. Oops. The d was 10, so 10 with a negative equals 5 delta t plus 1/2 of negative 9.8 t squared. When I put that in standard form, I'm getting 4.9 t squared minus 5t minus 10 equals 0. Unfortunately, this has turned into a quadratic formula sort of thing. You learned it way back in grade 9 or grade 10 math. If you have an app on your phone or Chromebook, you can get the computer to do the work for you. We're going to get two possible times. When I crunched it out, one of them rounded off to almost exactly 2 seconds, and the other one was almost exactly -1. The negative doesn't make sense. We're going to call it inadmissible. I don't know if I spelled that right. Inadmissible. It just doesn't make sense for there to be a -1 as our time for it to hit the ground. The equation doesn't understand the context. If this parabola was part of a bigger parabola, it would have been on the ground 1 second before it was at that height moving those speeds. But for what we're doing, the -1 doesn't make sense. So we can ignore the -1, carry the 2 forward. Now we finish it just like we always have. Now we know how long it's in the air. We can use d equals v times t to figure out how far it goes. For this one that I made up, it was thrown sideways at a speed of 8. And we just figured out it's in the air for 2 seconds, so it lands 16 meters away. The difference to this one is we had to do a little bit of more work in the vertical to get the time, but the steps were exactly the same. Also, we had to be careful in the vertical with our up and down. Now that we had an up as well as the down, we had to make sure our signs were done properly.